So this recording is continuing section 7.3. 7.3, we had two lecture notes on 7.3, and I changed the lecture notes a little bit, so I am doing the one that I already modified. So that is the one that is posted on our Canvas shell. So 7.3 continues. Problem 8. For each pair of vectors, find the magnitude and direction angle of the resultant, if necessary, down to 1 decimal places. So we have one vector that we're going to call A. So that's going to be 4 and 2. No, I'm going to call A is 4 and 6. And B will be 4 and 2. Resultant means sum. A plus B equals 8, 8. Find the magnitude and the direction angle of the resultant. So magnitude will be square root of 64 plus 64, square root of 128, which is about 11.3. Direction angle will be tangent inverse 8 over 8, which is tangent inverse 1 or 45 degrees. Number 9. A plane is headed due east with an airspeed of 300 miles per hour. The wind is from the north at 40 miles per hour. Find a bearing for the course and the ground speed of the plane. So here's like a little direction, right? North, south, east, west. The plane is headed due east with the airspeed of 300 miles per hour. The wind is from the north, so it's kind of like hitting on the nose of the plane from the north, 40 miles per hour. Find the bearing for the course and the ground speed of the plane. So this will be the speed of the plane. The wind is the 40, so we're gonna look for the resultant. So for step number 1, we're gonna find the resultant, which is from Pythagorean identity, this is a right triangle. So let's label this with C. C squared equals A squared plus B squared. C squared equals 300 squared plus 40 squared. And take the square root. C equals 32.7 miles per hour. For problem 2, we're gonna find, so I'm just gonna make this little triangle here. So this is 300, this is 40. So this is, let's say, we call this C. This is gonna be alpha and beta. So we will be looking for beta. So we can use, we have an opposite side and an adjacent side. So beta equals tangent inverse opposite over adjacent. So that will be about, let's see, Second tangent 40 divided by 300. 7.6. That's going to be the drift. So the plane is, instead of completely going east, it's kind of drifting away since the wind is blowing at it. And then to find the bearing is, remember we always measure it from the north. So this is the 90 degree plus the beta. So 90 plus 7.6 will be the 97.6. That will be our bearing. And the speed is the 302.7 miles per hour. Number 10, an ultralight is flying northeast at 70 miles per hour. The wind is from the north at 20 miles per hour. Find the bearing for the course and the ground speed of the ultralight. So I'm just going to make a picture over here. Northeast. So that's going to be this direction. 70 miles per hour. The wind is from the north, 20 miles per hour. Find a bearing for the course and the ground speed of the ultralight. So we'll have, here's my triangle. Northeast means this angle is 45. So this angle will also be 45. So we have a triangle ABC. (45, 70, and 20). I label them ABC like this, A, B, C. So we can find this side. So actually, let's label it differently. So A, B, and C. So side C. C squared equals A squared plus B squared minus 2AB cosine of gamma. So C squared equals A is 20 squared plus 70 squared minus 2 times 20 times 70 cosine 45. C is approximately 57.6. So that's going to be our ground speed. And for step 2, we will solve for this angle, right? Sine of alpha over 20 equals sine of 45 over 57.6. So alpha equals sine of inverse 20 times sine of 45 57.6. So the angle is about 14.2. Again, that's the drift. So instead of heading directly to northeast, right, it's kind of drifting a little bit because the wind is blowing at the ultralight. So now we have this angle. We always measure it from north. So we have, this is 45 degree now. So we're gonna add the 45 plus the drift, which is 59.2, will be the course of the ultralight. So this is the second part or the end of 7.3.